Now, potassium dichromate is one of the most important compounds of chromium and is important industrially also. Potassium dichromate, as you can see it on the screen, K2Cr2O7, it is being prepared from chromite ore, which is FeO.Cr2O3 or FeCr2O4. That is a chromite ore. Now, how do we convert it? First of all, we convert chromite ore to sodium chromate. That is, you can see it on the screen that chromite ore reacts with sodium carbonate in presence of oxygen to form to sodium chromate. The first we convert into sodium chromate. Now, after obtaining sodium chromate, what we do is that we are reacting sodium chromate with concentrated sulfuric acid. Alright, that is we are heating first, that is with sodium chromate, that is roasting is being done. Or upon roasting, we are getting, that is what you can say, we are getting, that is nothing but Na2CrO4, we are getting it upon roasting. Yellow mass containing sodium chromate is obtained, that you can see it on the screen. Now, quicklime makes the mass porous and thus facilitates oxidation of the ore by air. Got it? Now, as I said, the next step is that we convert the sodium chromate into sodium dichromate. The next step is Na2CrO4, you can see it on the screen, which reacts with concentrated sulfuric acid to form Na2Cr2O7. So, we converted, the solution thus obtained is concentrated when less soluble sodium sulfate Na2SO4.NH2O crystallizes out. Alright, that is Na2SO4, it's being formed here, as you can see it on the screen. The second step, it crystallizes out, it forms Na2SO4.NH2O, which is being filtered hot. We are filtering it hot so that it crystallizes out. The solution is now allowed to cool, and when sodium dichromate crystals Na2Cr2O7.2H2O separates on standing. Alright, clear, understood? We are filtering. Upon filtration, we are getting, that is crystals of sodium dichromate. Fine. Now, sodium dichromate is reacting with KCl to form potassium dichromate. Sodium dichromate is more soluble and less stable than potassium dichromate. You noted this point, very important. Sodium dichromate is more soluble and less stable than potassium dichromate. The latter can be prepared by treating the solution of sodium dichromate with potassium chloride. In actual practice, a hot and concentrated solution of sodium dichromate is treated with calculated amount of potassium chloride, and the mixture is allowed to cool when orange crystals of potassium dichromate is obtained. Alright, and actually we do that. In theoretically it is written that we are first getting sodium dichromate, after filtration, that is hot solution, it is allowed to stand to get crystals of Na2Cr2O7.2H2O, then it is reacting with potassium chloride. Alright, but actually we do not do so. Actually what we do is that a hot and concentrated solution of sodium dichromate is treated with calculated quantity or calculated amount of potassium chloride, and the mixture is allowed to cool to get orange crystals of potassium dichromate. Fine. This is how do we prepare potassium dichromate. Three steps are there. First is roasting, second is reaction with acids, conversion of chromate into dichromate, and the third is conversion of sodium dichromate into potassium dichromate. I hope you understood. Now, potassium dichromate formed orange crystals. You can see the structure here, the potassium dichromate structure. I have shown it to you here, the chromate ion and the dichromate ion. You can see it there on the screen very clearly. So practice this particular structure, and you may get it in your exams. You might be getting it this structure. So the chromate ion possesses a tetrahedral structure. You can see it there, the chromate ion on the screen. It possesses a tetrahedral structure with 4 oxygen atoms are arranged in a tetrahedral angle, we can say that, and sharing with one corner with other chromium corner, the bond angle is 126 degree. Alright, the bond angle is 126 degree. That is in case of dichromate ion, you can see is there. That is the two structure I am showing you, the dichromate structure as well as the chromate structure. You can see it there. The dichromate ion consists of the two tetrahedra, isn't it? You can see it on the screen that it consists of two tetrahedra in which the bond angle between the chromate, oxygen and chromate, the chromium, sorry, chromate I am saying, that is a chromium, oxygen and chromium in the middle. that is 126 degree, and the bond length is 179 picometer between chromium and oxygen, we can say that. Clear? So it is a tetrahedral structure, and you can see the structure of also potassium dichromate, you can see it on the screen. Clear? So it's a very clear cut structure, you can see it here. Now next is that is we will see some properties of the potassium dichromate. It's orange red crystals, and its melting point is around 700 Kelvin. It is soluble in water. Just now you studied. Now potassium dichromate on heating will give you potassium chromate plus chromium oxide plus oxygen. You can see the first reaction I have given you. That is K2Cr2O7 upon heating will give you K2CrO4 plus Cr2O3 plus oxygen. Now when it reacts with alkalis, then also you will get potassium chromate. Remember it. It is yellow colored. Potassium chromate is yellow colored. Potassium dichromate is orange colored crystals. Now on acidification, potassium chromate reacts with sulfuric acid to form, that is potassium dichromate. First, potassium dichromate reacts with KOH, that is an alkali, to form potassium chromate, that is reduced. Mind it, it is reduced. Now from orange colored it gets yellow colored. On further acidification, again potassium chromate, it's getting converted into potassium dichromate. Remember this, very important. That is, I repeat the reaction, K2Cr2O7 plus KOH will give you K2CrO4 plus water. Now K2CrO4 plus H2SO4 will give you again K2Cr2O7 plus K2SO4 plus water. K2Cr2O7 plus K2SO4 plus water, we can say that. Clear? So you can see it here, there exists an equilibrium between the chromate and the dichromate ion, we can say that. You can see very clearly. So when that is dichromate, potassium dichromate reacts with acids, you can see it forms chromic anhydride, potassium bisulfate, and water is being produced. Now when potassium dichromate reacts with sulfuric acid, got it, it forms potassium sulfate. You may write down this reaction, I am telling you. K2Cr2O7 plus 8H2SO4. Again I repeat, 2K2Cr2O7 plus 8H2SO4 will give you 2K2SO4 plus 2Cr2SO4 whole thrice plus 8H2O plus 3O2. Again I repeat, 2K2Cr2O7 plus 8H2SO4 will give you 2K2SO4 plus 2Cr2SO4 whole thrice, 2Cr2SO4 whole thrice plus 8H2O plus 3O2. Got it? So this you get the reaction with sulfuric acid. Same thing you can get the reaction with hydrochloric acid also. That is, when potassium dichromate reacts with HCl, K2Cr2O7 plus 14HCl will give you 2CrCl3 plus 2KCl plus 7H2O plus 3Cl2. Write down these two reactions. K2Cr2O7 plus 14HCl will give you 2CrCl3 plus 7H2O plus 2KCl plus 3Cl2. You can see it on the screen also, it is being there. You can see the reaction is there on the screen. There is a first, second, third, fourth, fifth reaction. You can see it on the screen, it is being there. So now next is you can see that it liberates what you can say iodine when it liberates iodine when it reacts with potassium iodide. When it reacts with potassium iodide, it liberates iodine. You can see the third equation on the screen, that K2Cr2O7 when it reacts with H2SO4 with Ki, it gives you K2SO4 plus chromium sulfate plus iodine plus water. You can see that. It also oxidizes, that is nothing but ferrous sulfate to ferric salt, because potassium dichromate, you know, it acts as an oxidizing agent. It not only oxidizes ferrous salt to ferric salt, but sulfide to sulfate, hydrogen sulfide to sulfur, many things, many such reaction you can get it. Many such reaction you can see on the screen, that is sodium sulfite is being converted into sodium sulfate. The fourth equation you can see it on the screen. K2Cr2O7 plus 4H2SO4 plus 3Na2SO3 will give you K2SO4 plus Cr2SO4 whole thrice plus 4H2O plus 3Na2SO4. You can see it on the screen, the fourth equation. So in this way it oxidizes. In this way many substances it oxidizes arsenides to arsenates, we can say that. Clear? It oxidizes ethyl alcohol to acetaldehyde. You have read it in the what you can say in the organic chapter. That is K2Cr2O7 plus 4H2SO4 will give you K2SO4 plus Cr2SO4 whole thrice plus water plus nascent oxygen, 3 nascent oxygen. This nascent oxygen, that is the 3 nascent oxygen which is being produced, it reacts with alcohol, ethyl alcohol, to form acetaldehyde, which is unstable, you know that. Acetaldehyde further reacts with the nascent oxygen to form acetic acid. Alright, it forms acetic acid in this way. Clear? So in this way you get it, this particular reaction, that is, it acts as an oxidizing agent. Please you do one thing, you just what you can say, this practice these equations, then only you will be sure of. Alright, practice these equations. Now very important test is there here, chromyl chloride test. It's a very important test, you might have done in the lab. When solid potassium dichromate is heated with concentrated sulfuric acid, alright, and soluble metal chloride like NaCl, KCl, etc., you can say that. So what happens is that you get chromyl chloride, Cr2OO2 Cl2. The last equation you can see that K2Cr2O7 plus KCl plus H2SO4 gives CrO2 Cl2 plus KHSO4 plus water. That is, CrO2 Cl2 is your chromyl chloride, which is being obtained, we can say that, on heating, which is an orange red colored vapor. Orange red vapor, that is chromyl chloride, and this test is said to be as a chromyl chloride test, we can say that. So chromyl chloride vapors, when passed through water, gives a yellow solution to the formation of chromic acid, we can say that, H2CrO4, a yellow solution of chromic acid, you get it. Now chromic acid reacts with lead acetate to form lead chromate and acetic acid. Alright, it is a test used for the detection of the chloride ions. It's a test which is used for the detection of the chloride ions. This particular test which I said you, it's a test used for the detection of the Cl minus ion, the chloride ions. Again I repeat, the chromyl chloride which you got it, there is orange red vapors. First it is being passed through water, chromyl chloride plus water, it gives you HCl plus H2CrO4, chromic acid. Chromic acid H2CrO4 reacts with lead acetate, CH3COO whole twice Pb, to give lead chromate, PbCrO4 plus acetic acid. PbCrO4 is a yellow PPT. Alright, yellow PPT, which is a test for what you can say chloride ions, we can say that. Now this is about your potassium dichromate, we can say that. Potassium dichromate also, it is being used when it reacts with lead nitrate or the barium nitrate, the salts, the soluble salts, we can say that, with water to form again lead chromate, that is an insoluble yellow PPT is being formed. Got it? So it's also used when it is also we are also getting that is lead chromate when potassium I'm saying lead nitrate or barium nitrate reacts with potassium dichromate. Okay, now it is an oxidizing agent, already I said you, it is used for the chromyl chloride test. This particular one, it is used for the preparation of the lead chromate and all. Thank you.